In 11.4, we will be talking about properties of logarithms. At the top of this page, you can see that we have kind of a chart that gives us examples and the definitions of the different properties. You can see we have the product property of logarithms, the quotient property of logarithms, power, and equality. So I would take a few minutes and pause the video and kind of get yourself familiar with these. You can see that the product, what happens if it's multiplication, is it can split it up into two logarithms through addition. In division, it splits with subtraction. With the power property, this exponent right here actually goes in front and becomes a multiplier. And then the equality and we shows that if the base is the same um, in those, then those numbers will end up being the same. So what we're going to do with some of these, especially at the beginning, it was just going to show how we can rewrite these. And we're going to expand them and then also condense them based on what is given. So if you look at number one, if you look at number one, you have log base 4 time of the quantity 3 times 7. So since it's multiplication, what happens is we can expand that into two different logarithms through addition. And we just separate them. If we look at number two, you see how they're expanded out through addition. And so what we can do is we can condense them by taking the 10 and the 3 because they have the same base, and I guess that's important to realize that they have the same base. We can bring them together through multiplication and then actually evaluate it. Log of base 8 to 30. Over here we see that it's division. So what we're going to do is we're going to separate these two out with subtraction. So we're expanding that. Over here, you'll see this is the first one that we have with an exponent. So what happens is this exponent goes in front as a multiplier. So it becomes 4 times log base A of x. Number 5, we're going to condense this again. So again, it's subtraction, so that means we're going to bring it together through division. Log base 3, because they both have the same bases. The p goes in the numerator, and then we do division by q. Number 6 is a little bit trickier because it does have this radical sign in this, and you just have to kind of go back to thinking about those properties that we know before. So we have log base 2, and what I'm going to do is I'm going to rewrite this. It's x to the 4 over 7. Because remember, you can really write a radical as a rational exponent and vice versa. Now, this exponent right here is going to move out in front, so it's going to be 4/7 times log of 2 to the x power. Again, we see that this 8 and this k is separated through multiplication, so we're going to expand that. Log base 8 of 8, and then I'll do plus log base 8 of k. And then what you should notice right here is that these both have 8 and 8 in there. And if you remember back to the previous video that we talked about, when this happened, that simply evaluates down to 1. So I have 1 plus log base 8 k. We're going to do something similar with number 8, but we're going to play around with how to evaluate this down even more based on the numbers you're given. So I'm going to expand this because this is division, so log base of 4, 3, and because it's division, I'm going to use subtraction. Now, it was really convenient in number 7 that 8 and 8 were the same. And if you look at number 8, 4 and 16 4 goes into 16 evenly. So what I'm going to do is I'm going to rewrite the 16. I'm going to rewrite it as 4 squared. We'll keep that first term the same. That 2 is going to come out as a multiplier, so it's going to be 2 times log 4. And again, because these are the same numbers, that evaluates down to 1. So 1 times 2 will just be 2. So log of the base 4 to 3 minus 2. Number 9, what we see here is that it's expanded, and we're going to try our best to see what we can do to condense this. You'll notice that there are 1, 2, 3, 4 of the exact same logarithms, so I'm going to write that as log, 4 log of 4 to the of 5. And having a multiplier out in front can also be rewritten as the exponent. So log of 4 to 5 to the 4th power. And then 5 to the 4th power is just 625. Number 10, as you can see, is pretty condensed. So again, what I'm going to do is I'm going to try to expand that. I'm going to separate these out using addition because it's multiplied. Because 6 and 36, I can see that 6 goes into 36. I'm going to rewrite 36 to use that same base. So it's going to be 6 squared. I know that 5 being out in front can become a multiplier. And I'll do the same thing with this 2. I'm going to bring that out in front as well. So 2 log base 6 is 6 plus 5 log base 6 of m. This will become 1. So it's 2 plus 5 log of 6 of m. All right, we're going to finish this video with 2 more. And I want you to look at this. This looks like it's pretty condensed, and see if we can kind of expand this. But if you look at it, there's a plus sign in the operation. And if we scroll back up to, our definitions, notice that it's multiplication and division that allows us to separate, not addition. So this one actually right here is already simplified or expanded, so it cannot be rewritten. All right, and then let's take a look at number 2. Again, this is pretty expanded form, so we're going to condense this. Again, when I have a multiplier out in front, I'm going to write that as an exponent. Log base A x squared plus log base A y to the 3rd. And because it's plus, I want to join them together because they have the same base by multiplication. And again, I'm not going to do with anything with those exponents because those bases are the same. I can't bring them together anymore. All right, in the next video, we'll simplify a couple more examples, and then we'll talk about how you can evaluate logarithms, also given values with certain logarithms.